Yo, what's up everyone? Patrick here, welcome back. And moving on to a couple of more expressions we have to simplify using exponent law. So just some more practice, some other different formats that you could run into when dealing with exponents. So starting with number 1, we got 4 to the negative 1 over 3 to the negative 2, all to the power of negative 2. Now a couple of things you can do. You could take this. First off, we could flip this fraction because it's a negative exponent, and then we could take that exponent outside of the fraction, take it to the numerator and denominator. That's one way to go about it. Personally, what I like to do is I like to first simplify the bracket as much as possible and keep positive exponents, because if you start having too many negatives, you could start slipping and missing stuff. So here, this bracket, I'm actually going to change to 3 to the power positive 2 over 4 to the power of positive 1. And then that exponent on the outside is still going to stay the same. So I took this negative exponent, brought it up, took this negative exponent, brought it down. Those negative exponents changed to positive. So this would end up being 3 to the power 2 is 9, 4 to the power 1 is 4, and then that would be to the power of negative 2. And then this is a lot easier. Flip the fraction. That changes to a positive 2, then we take 4 to the power 2, 9 to the power 2. So it'd be 16 over 81, like that. That's what the final answer would be to this question here. Now, if you went about it that other way, dealing with the outside exponent first, again, just be careful with the negatives, and you should get the same final answer. Now, this one's a little bit unique. 3 to the power negative 2. Bracket 3 to the power 3 plus 3 to the power 2. Now, what you can do here actually is you could take this and distribute it to these two. This is like in the format ax plus y, which is the same as ax plus ay. The reason why you can, or it might be a good idea to do that, is because all these bases are the same. So when we do end up multiplying these terms, the multiplication is going to be fairly smooth. So I took that 3 to the negative 2 and just distributed it to both terms like that. And so negative 2 plus 3 gives us 1. And then negative 2 plus 2 gives us 0. 3 to the power 1 is 3. 3 to the power 0 is 1. So the answer is 4. That's the final answer to this. Another way you could have went about this is 3 to the negative 2, we would change that to 1 over 3 to the power positive 2. Then 3 to the power 3 is 27. 3 to the power 2 is 9. And this would end up being 1 over 9 times 27 plus 9 is 36, which would give us 36 over 9, which would be 4. Okay, so that's another way to go about it, but kind of wanted to go about it in a unique way just to show you that we can distribute here. And then since these were the same base, then the exponents ended up being fairly nice. In this case, because the base is very simple, 3, it's easy to go about it this way. But what if this was like 23? Okay, and let's say you weren't using a calculator. You weren't allowed to use a calculator here. Well, 23 to the power 3, 23 to the power 2, that would be a lot of manual algebra then. And then 23 to the negative 2, that'd be 1 over that big number. So instead, if you distributed, you'd end up with 23 to the power 1, 23 to the power 0, which would be 23 plus 1, which would give you 24. Right, so in this case, because we're dealing with 3, it does look more simple maybe to go about it this way. But just be aware of this method here in case those bases get fairly large. So we got 4 for the final answer here. Now these two are going to be fairly algebra heavy, and the reason why is because we have this positive and minus. So we have a fraction, an overall fraction, but within the numerator we got this positive and minus. And again, I mentioned this in a previous example, there's no positive minus here. So you can't really like combine these two or apply some kind of law. You have to actually deal with them separately. So this would be 1 over 3 to the power 2 plus 1 over 2 to the power of positive 3. If we take these and apply this rule, and that's going to be all over 1 over 3 to the 2 minus 1 over 2 to the 3, like that. So I took each of these individual terms, change them into fractions. So we'd end up over here with 1 over 9 plus 1 over 8 all over 1 over 9 minus 1 over 8. And what I would do here is combine the numerator to be one fraction, the denominator to be one fraction. So the common denominator is 72 between these. Multiply this by 8, multiply this by 9, multiply this by 8, multiply this by 8. By 9, right? And so we'd end up with 8 over 72 plus 9 over 72 all over 8 over 72 plus, or minus rather, 9 over 72, right? So lots of algebra going on here. And then 8 plus 9 would give you 17 over 72 all over 8 minus 9 would give you negative 1 over 72, like that. So then, now it's a little better because we got one fraction divided by another fraction. So this would end up being 17 over 72 divided by a fraction. That's like multiplying it by the reciprocal of that fraction, and then the 72's cancel out. 17 over negative 1 gives us negative 17. So that's what the final answer is to number 3 right there. Number 4, it's actually going to be a little trickier. Notice that the only difference here is that this exponent was a positive and then this exponent is a positive now. And I feel like it actually does make things a little more complex. The 3 to the negative 2, as we've shown there, is 1 over 9. But then we have plus 8 over here. And then this would be 9 plus 1 over 8. The 2 to the negative 3 is 1 over 8, like we showed in the other example. So this is going to be over 1. This is going to be over 1. So we would multiply this by 9 to get a common denominator. So we'd have 1 over 9 plus 72 over 9. Maybe it's not more complex. Multiply this by 8, common denominator, this by 8. So in this case, the common denominators are different in both the numerator and denominator, versus before the 72, they were the same, right? And it's because one of those terms stayed up top in the numerator, the 8 and the 9 in the denominator. Okay, so we have this. Let me just make sure that we're all good here. Yeah, it looks fine to me. So we'd end up with 73 over 9 divided by 73 over 8. And then continuing this over here, we'd have 73 over 9 divided by a fraction. It's like multiplying it by the reciprocal of that fraction, which would be 8 over 73. And so in this case, this and this cancel out, and we end up with 8 over 9, versus here, this and this canceled out, here, that and that canceled out. Right, so 8 over 9 would be the answer to number 4. So with these kinds, especially when you see this plus and minus, remember you can't really apply certain laws. Most of these laws, the terms are sort of like together, if you notice, or they're like multiplying, dividing. You don't see any plus or minuses besides the exponents, but in terms of adding or subtracting actual terms, you don't really see that over here. So just be careful with these. You can't really apply exponent laws there. You got to deal with those terms separately.